By Rob Herring, who's part of Octo and is currently working on Project ARA. And who else do we have in the front here? So where are my other Linaro helpers? Disappeared. Anyway, okay, we'll see how we get on. So what I really wanted to just cover in this session is and I want to make it interactive, give you a little bit of background to 96Boards hardware specs, focusing on the consumer edition, but also talking about the enterprise edition, kind of what our design choices were and what member input we had as we did this, because we didn't do it in a vacuum. We talked to a number of members, and we also talked to a number of people in the community about what they would like from such a platform. And inevitably what we end up with is, to a certain extent, a compromise. But interested in your input and commentary. So this is what I put up this morning. 2 different specifications, don't need to cover that again. But if we start diving into a bit more detail on the consumer edition, the key use cases that we got from the community and from our own requirements were that we wanted to deal with software, be able to enable software development. We wanted to enable the maker community, particularly around things that require a reasonable level of processing performance. So that's robotics, UAVs, and also potentially the interface to IoT. And that's a very wide topic. Higher education, so not necessarily kind of getting kids started, but at the next level actually moving up to university kind of environments where the problems are bigger. And then embedded OEMs. One of the challenges with existing community boards is they tend to be modified. They tend to have to be taken and then redesigned for industrial or embedded applications. But we've had a clear indication that one of the challenges for ARM in the embedded space is that it's actually difficult to use ARM products in embedded products because of software problems, and every time a peripheral needs to change, you need to, every time you change an SoC or change a peripheral, you need to change the software and so on. So a product that could be directly used in an embedded product was something that was asked for. So our design goals were really to make the thing ultra compact. Technology will always move forward. Just because it's hard to lay out and get on a board today means that in 18 months it'll probably be pretty easy. So that was one of the goals. Make the thing as low profile as possible, lightweight, so it fits into a small space. Assume we're using mobile and embedded low power SoCs as the basis of this. And a slightly controversial one, but when we're in the 21st century, focus on wireless, particularly Bluetooth, because of the increasingly wide applications of Bluetooth LE, particularly as we move into IoT. And also therefore put Wi-Fi on the board as well and require those, as opposed to the other way around, requiring Ethernet and making wireless optional. So that's a difficult decision, and we'll come to it in a minute. Quick hardware summary. So this is the minimum feature set for the consumer edition, 0.5 GB of DRAM. That's really more for the embedded guys. Once you start wanting Android, particularly on a 64-bit board, you've got to have at least 1 GB. There are companies who are building and designing boards with 2 GB. Wi-Fi, Bluetooth LE, just discussed. Display interface. It is a moment in the spec a requirement that there is, well, there's 2 requirements. One is that there's a local display interface, so HDMI, but you can have something else like MHL if you want to. And then a DSI interface out onto the expansion connector. And one of the things that Steve Taylor's looking for is to work with OEMs to build a intelligent display module that just goes straight down onto the board, tablet kind of size display. USB ports, I'll come to in a few minutes. Audio, the minimum requirements are audio via Bluetooth and via the display. Putting additional audio onto the board, so for example, stereo jacks is optional. Standardized power supply, we really wanted to make this thing powerable from USB. But when you look at some of the SoCs that are around today, 8-core A53s, they tend to use a fair amount of power when they're going at full usage, and you just don't get enough power off a USB micro, off a micro USB. That will change once we go to Type-C connectors, because on a Type-C connector you can get 60 watts of power into the board. So that's something that we allowed in the spec for the future, to actually use USB Type-Cs for the power supply. But there is an external standardized power supply, notionally 12 volts at 2 amps. And standardized low and high speed connectors, which we'll talk about in a moment. Other required features: low profile, so 7mm board-to-board separation for the mezzanine modules. You can power the boards either from the connector onto the board, but you can also power it down from the mezzanine modules. So if you're building an intelligent display product or something where you've got a big meaty power supply for the display, you can actually use that power supply to power the board as well. For our own purposes in the power management group, we wanted to see current sense resistors to do power management measurements. The more the better. You do have to watch out for PMIC limitations. Most of the PMICs are very sensitive to putting any additional voltage drop in their output lines. So how much you can do without a lot of cost depends on your PMIC implementation. You've got to have a power reset button, you've got to have some user LEDs, and the connectors must be placed in the designated positions for 2 reasons. One, obviously, for compatibility between different boards, and the second, so that we can easily design test farms to put all of these boards into. Low-speed expansion connector, we had a lot of debate about this. We talked particularly to CircuitCo and a couple of other companies who have experience in this area. And the recommendation was that be very careful making 1.8 volt interfaces on a 0.1 inch spacing, because the maker community will start plugging things in that will blow up your relatively expensive SoC. So the other comment was, well, make the I/O 3.3 volts or 5 volts, because that's what everybody does. When you actually start thinking about this, if you're actually building an embedded product, the module that you're interfacing to may well be a 1.8 volt module anyway, something like a display interface. So what you don't want to do is go to the cost of level shifting up to 3.3 or 5 volts on the baseboard and then shift it back down to 1.8 volts on the module. That's crazy. So we ended up saying we're going to start with 1.8 volts because that's what's supported on most SoCs, and therefore we put it on a 2mm connector to give a signal to the maker community that you just need to watch out what's on this board. One nuance mandatory, the second optional. There's an SPI bus that you must have, mandatory I2C buses, mandatory 1 audio bus, which can be I2S or PCM, 12 GPIOs, reset and power, and power lines. So most of those things, if not all of them, are relatively easy to find on any SoC. The high-speed connector is an impedance match connector. It's designed so that if you use both connectors, you end up with a nice level board separation to 7mm apart. MIPI DSI 1 to 4 lanes, and the camera interfaces we ended up making optional. There are 2, basically the input we had is the more the better, particularly for robotics implementations. So you can actually put a stereo camera on the CSI0 and have a third camera if you want to, depending on whether your SoC supports it. There's another SD or SPI interface on the high-speed connector, and then a USB host interface which can be high-speed. And a couple of I2C buses are optional. If you have CSI, some cameras need a corresponding I2C. And then HSIC is also optional. So mezzanine boards and modules. You can connect mezzanine boards and modules to the low-speed connector or the high-speed or both. They can be any size. We've still got to do some work on speccing how to do modules. But the idea is there's 2 types. There's a small module, which is the same or smaller footprint than the board itself. and then there's a large module that can exceed the 96 boards footprint. So if you think about a display, big display, plug the board in the back, that's an example of a large module. There is a company who's designing a Arduino Uno compatible maker module that will have Arduino Uno interface. We'll also have level shifters for 3.3 and 5 volts low speed expansion I/O on a standard 0.1 inch header. And we'll probably also have a couple of Raspberry Pi compatible camera connectors. And that board will work on, it's a small board, it's the same size, credit card size, and it will work on any 96 boards board. Just plug it in and it'll work and it'll provide the same functionality. So it'll be interesting to get some software. This is a hardware session, but it'll be interesting to get some standardized software tools for that. And we're looking to get a display module built as fast as possible. It's interesting for the Raspberry Pi. It's taken them 4 years to get a camera module on their DSI interface. Okay, so things to watch out for if you're designing a board or looking at designing one. Firstly, USB. Many mobile SoCs, the only USB port on them is one OTG port. And so turning that into, so there was a choice here in the design phase as, well, do we just make one port the minimum? And a lot of community boards, a lot of usage just depends on plugging in USB peripherals, and so requiring a bridge to do that we thought was probably not the right thing. So boards typically support multiple USBs. So the result is that in most cases a mobile SoC is going to need a hub, and the initial high keyboard that's been designed, if you look at the schematics for that are on the website, you can see how that's been implemented. As a result, you may have some restrictions. So for example, on high key, you either use the OTG port or you use the Type A ports. You can't use both at once. And there's also some restrictions in terms of the types of USB devices you put on each port. It's documented, you can read it, and you can get around it for most use cases. So USB ports can be micro USB and Type A, or you can use Type C connectors. The benefit of Type C connectors, apart from the fact that you don't have to try them 3 times before you get them in, you can put them both ways up. They're a bit like the Apple Lightning connector, but they can also carry a lot of power, and you can also put displays and things across them as well. If you're SoC
always super speed, or can it be?
Type C is super speed. No, but no, it doesn't have to be. It's a PHY, so you can put lower speeds on it, as far as I remember. Have we got any USB Type C experts here? Where's Leif? No, you'll need to read the spec.
I mean, I was wondering what 96 board says.
96 board says you can use a Type C connector, and the assumption is, as far as I remember, that a Type C connector, it's the USB 3.1 spec, you can run any speed on it that you want.
So the SoC you can use an SoC that only has
yes.
high speed?
Yes, that's my understanding. Power supply, I mentioned micro USB, why not use it for power? The problem is it's rated at 9 watts max and the peak requirements can exceed this. That's caused a lot of issues on things like Panda board, where boards were getting returned because basically they were browning out when you started to put use a lot of power out of the SoC, and actually you just needed to plug an external power supply in, but that actually caused a lot of cost. So the solution to that is use the external power supply, we require it, or put Type C USBs when they become available. Thermal is also a problem, particularly when you think about sandwiching a module on top of a board. So you've got a nice SoC that's warming up nicely, and you've got nowhere for the air to go. So even without a module on, modern SoCs can get pretty hot. If you actually run 8 cores at 1 to 2 gigahertz, you're going to generate a reasonable amount of heat. So software thermal management contains this at a cost of peak performance. You can actually place the SoC on the top or the bottom of the board when you're designing it, and if you're operating in a case or if you're using a mezzanine board, then we're recommending you put airflow across more airflow you get, the more performance you can get.
Sticking with what you've given us so far, have you got height restrictions for heat sinks
Yes.
on both sides of the boards?
Yes and no. There is a height restriction on the way the board's been designed is to allow lateral airflow across the board between the two connectors. I'll show you a picture in a minute. And there's height restrictions to keep the general level of the components low enough so that you can generate airflow across. The exceptions are heat sinks. So if you've got a heat sink or a fan that you want to put on top of that exceeds that still can fit but basically blocks air because it's moving air itself, that's fine. The other thing you can do is put a heat sink on the bottom of the board for if you put your SoC, if you mount the SoC on the bottom of the board, you can put a heat sink on the bottom of the board, and as long as you tell the user what to do, the spec says you can do what you want.
I'm thinking more of your test farms and bits and pieces. If you don't have a mechanical restriction on height, fine, I'll give you a board.
Well, exactly. Yeah, you can. I mean, the spec is the spec, right? If you want to, you can stick a board up here. It's up to you as a user, but it, yeah. Okay, I want Ethernet. Why can't I have Ethernet? Well, many mobile SoCs don't support it. You can use a USB Ethernet dongle on a high-speed connection, and that's not bad, and it's relatively cheap. The RJ45 connector's big and wouldn't allow us to achieve the low profile, even if we did want Ethernet on there. And if you still want it, then there are a couple of options. One is to go to the enterprise spec, which I'm going to cover in a moment. The other is to do the extended version of the consumer spec, which I will also show you in a moment. So here's the standard footprint, credit card size, showed you a board this morning. I've got one if anybody wants to have a look at it closer up. And as I said, we're going to hand some out if you've got a good reason for looking at it and using it. And this is what I meant by having this area here where you've got height restrictions on the components with the exception of heat sinks, and so you can get air across the board if you need to. So the interesting one is the second one. This is the extended version, which is absolutely compatible on the bottom. It's the same design. But basically extends the board to 100 millimeters by 85, giving you a lot more space. And because this connector can be surface mount, you can actually create a lot of space on the bottom of the board. So we've got some users who basically, rather than using a single LPDDR RAM, which would be a 32-bit device, they want to put 2 or 4 RAM devices on to get more performance. And there really isn't enough space to do that and put a PMIC and the SoC and so on this footprint at the moment. So in that case, you'd probably design it with the SoC on the underneath and 4 RAM devices, right? Or even an SODIMM. So there are 2 versions of this extension. One is to keep everything low profile. And the reason for that is if you've got a big module, like a display module that covers the whole thing. The other option is you have to keep to the height restrictions here, allowing you to put compatible small format boards on. And then you can put higher components here if you want, like like RJ45s or double stacked USBs. But in that case, you will not be able to fit any module that obviously extends this way. All right? Up to the designer. Okay, quickly touch on Enterprise Edition and then throw it open for discussion. So the Enterprise Edition specification, slightly different use cases, less for makers, more for things like build and test farms. So the design goals here are interesting in the sense that one of the questions we were asked is, well, why don't you use an industry standard ITX or a ATX format and put it in a PC chassis and that'll be great. Well, that's not really what we're going after. We're not trying to create a product here. And actually, when you start looking at this in detail, the smaller footprint standard server chassis boxes, there aren't very many boxes, there aren't very many boards, and things like power supplies and disk drive connections are just a complete nightmare. And you end up actually creating a pretty expensive system. So the goal here was drive down the cost as far as we can. If you want to put an external disk on, eSATA, right? Just go and buy a honking great disk drive with external power and use eSATA to talk to it. So the goal is a standalone board suitable for developer desks or for farms. cater for a wide range of enterprise SoCs. The spec is more flexible than the consumer edition, so that we can cater for server SoCs, networking SoCs, high-end set-top boxes, whatever. We haven't published this one yet. It's close to being published. We're in the process of the first design for a board to this spec. There's still limited option to make some changes as we finalize this. But at the moment, the board spec is 160, 120 board size, must have a gigabyte of RAM with 16 gigs strongly recommended, and we recommend SODIMMs so users can configure price storage to their own requirements. You must have at least 16 megs of boot ROM, and you must have somewhere where you can put 4 gigabytes of storage, either flash on board or an SD card on board or an eSATA interface. The footprint, anything in, this is actually supposed to be orange, is optional. So you've got to have a PSU. There's actually 2 PSU connectors, low-cost one barrel jack for low-cost power supplies if you're sort of under 60 watts. If you're over 60 watts, you can get up to over 100 watts with a special, there's a Molex high-power power supply connector here. Recommendation of SODIMMs, either vertical or horizontal. This is the area where the standard low-speed interface board can go on. So the Arduino board I was talking about earlier that goes onto the consumer version, you can also plug it onto the server version, right, if it's just using the low-speed connector. There's no high-speed connector on this because CSI and DSI you don't really find on server chips. So big space for the server. This is actually a relatively large space. PCIe 16-lane connector if you want it. It's optional. USB, we're actually probably going to make that mandatory. HDMI is optional. Micro USB for the debug UART or console UART. Then you've got to have at least one network interface, gigabit, could be more. And then you've got up to 3 more network interfaces, and you can optionally put a couple of eSATAs on. And then you can do whatever else you want. Future ideas. One of the things we've been asked for is to look at kind of going lower end, and so possibly whether we should create a kind of embedded application which would be a subset of the consumer edition, no high-speed expansion connector, optional display and optional other I/O connectors, and that would get you down to the sort of configuration that you see on the Raspberry Pi 2, where you can have, really you can configure the board with what you want and really drive the cost down, still maintaining the low end, the low speed connector, so you've got the same compatibility with boards that just implement the low speed connector. So that's a very quick tour around the hardware. We've got another session next, I think, that's going to cover software implications of all of this. But happy to start a discussion around hardware interface. Andrew.
So you said that the specification's open. How open do you mean? As in, will you be willing to accept external requests or discussions on features to include or to remove, etc.?
Yeah, so there's a couple of things here, right? First is specifications like this are very difficult to change once you've got initial boards out there. So, for example, moving the connectors or changing the functionality of the connectors that are there is generally a really bad idea, because anybody who's started to work on the existing design is going to be messed up. However, things like adding mandatory features, for example, or adding a third connector for something, or saying you must have this in addition, could be added later. It's an open specification to the extent, from a legal point of view, that anybody can design a board to the spec, or indeed to a variant of the spec, without any cause for, there's no royalty, there's no payment, there's no nothing. If they do that, they can't call it 96Boards, right? It's a bit like Arduino or anything else. So anybody can go and create a derivative product, and that's fine, or they can copy the exact spec, and that's fine as well.
So what license is the spec on that?
The spec is copyright Linaro, actually.
But what license?
The skin, well, it isn't. We haven't put it under Creative Commons yet, we're still in discussion with that. The schematics of the first board are under Creative Commons share alike, right? We'll probably do something similar for the spec, right? We haven't quite decided that one yet. We want some actual input from the people who are actually doing the first boards. The idea is that the companies who commit to the program and build boards will be a member of the steering committee of this LCG, and the steering committee of LCG will be responsible for maintaining the spec. So if companies come up with input, then that will go to that steering committee, and that steering committee will decide to upgrade the spec, change it, edit it, whatever they like. So it will be in control of the steering committee. Okay. Other questions? Yes. Okay.
So the 7mm height requirement seems to have resulted in a certain amount of compromise. Like you get the little 0.1 inch square serial header, which gives you 4 opportunities to plug your serial on wrong. Do you think that was necessary? Is that really what people wanted?
So, depends what your application is, right?
Yeah.
So, first thing is, what you end up with is a board that actually can be used in a lot of, whoops. That's called the drop test. That can be used in a lot of different very low profile and small format applications like robotics, UAVs, and so on. The trade-off is that you have certain constraints in terms of obviously vertically mounted components and also thermally. The 4-pin header that you first saw on, we made an initial prototype batch, I think, of 50 boards. And because of the way the high silicon SoC worked, we actually populated those boards with a debug header that you will actually never need, even if you brick the board, once we've actually got our own bootloader on it. Because you can actually restore the board through fastboot onto the micro USB. So the production boards are not populated with that connector. That connector was only for the initial bring up for debugging purposes. You can put it in if you want. We've documented it. The holes are still there, so you can add it if you want. So all of the connectors are actually just coming out nicely from either the front or the back. And then
So there is no serial by default, in fact, is that?
There is a, so the serial console, there are 2 options, right? The serial console comes out of UART 0 on this, and you can put a pin header or have a board that comes out to a nice FTDI connector. The other place the console comes out is on HDMI and USB input.
Right, but as you say, it's a compromise between actually being able to use the board in real things versus being a bit more convenient for developers on the desk.
So what I suspect is that somebody will come up with a very small little board that plugs onto here that brings out the UART onto an FTDI USB. Yeah, and then it'll work on any board. That's the nice thing. It's people want to do these convenient things. It'll then just work on anybody's board.
Okay, 2 questions fairly quickly.
Yeah.
The first one is you've indicated that you're expecting people to use these perhaps embedded in product or test in bits and pieces. Does that mean this is fully standards compliant, CE marked and
CE, FCC
compliant and so
yeah,
on?
so, well, Linaro doesn't make hardware. The spec doesn't require you to be FCC compliant. However, these days, most people who make these kind of boards, in terms of manufacturers, do tend to make them FCC and CE compliant. This particular one, this first one, is FCC compliant. We are actually using a pre-approved module for Wi-Fi Bluetooth, which means that you don't have to go through full radio emission testing when you're doing the FCC. And so, however, if you go and plug a external antenna on, then you theoretically are not approved anymore. So this actually uses a PCB antenna, but it also has a capability of putting an external antenna socket in, at which point it would not be approved. But typically on these boards, what we see nowadays is they are generally approvals.
Okay. The other thing you'll notice is you've specified quite a tight I/O requirements. How do our SoC manufacturers differentiate their products, as a lot of the key features of ARM-based SoCs is there's this lovely wide diversity with lots of different I/O available, and that's how you select your part. I mean, is this turning to be sort of, we're looking for a generic SoC and everybody makes the same?
So I don't think so. In terms of, this is a minimum specification, right? Vendors are free to differentiate in any different way they want as long as they don't go out of the minimum spec. The problem is that as implemented in an initial implementation, if you're using an SoC, for example, that doesn't have an HDMI interface, as this one was, you have to have a bridge between DSI and HDMI. You may need a USB hub. You're starting to use board real estate to implement the actual functionality. On the other hand, an SoC, for example, for digital TV market that has, I know one company who's designing a board that already has an HDMI directly on their SoC that puts out 4K video. They're actually going to have quite a bit more space because they haven't got to, well, it's actually not a very big chip, but they haven't got to have the DSI to HDMI config, and they can use that for something else. We also deliberately left some areas of the board that don't have connectors on, so you can add some I/O, and obviously then if you do the extended board, you've got a lot more flexibility and you can start putting in additional functionality. So I think we'll see how it goes. Certainly we have there are 4 or 5 designs I know that are in progress. Each one of them is different, actually, either because of the number of cores, 32 versus 64-bit, the multimedia kind of functionality they're putting on. Audio is another area that we're seeing some differentiation. So I think you will see differences between boards.
Eddie.
Yeah.
Minor nit.
Sorry.
The PCB mounting holes seem very, very small. In fact, 440 standoffs and 316 mounting bolts don't go through them. I had to take them and put it on a drill press so that I could mount it. Do you have, are you thinking about changing that?
This is actually a metric design in terms of its dimensions, and it's dimensioned for M2.5 screw holes. The reason is that when you have a credit card space, actually the screw holes take up a lot of space because then you need the spaces around them, and so we went with M2.5, which is bigger than M2 and not as big as M3, but it was a compromise. It's fairly obvious, right? Arndt?
This is getting a little into the software question, but you mentioned that there are 32-bit platforms coming up. That obviously means we can't run the same kernel on all of them anymore. Are there any other reasons? Like, do we expect to have more than 2 kernels?
I hope not. However, as you know, every SoC vendor carries an awful... So it depends what you're using it for. The question of can you get the kernel running on an SoC? Yes. Does that use all the functionality of the SoC? Inevitably no, because there's always the proprietary stuff and the binary blobs that you need that you have to add on and license separately, right? So Mali or... and so on. So yes, what we hope is that one day there'll be something with truly open source graphics and open source everything, but it's going to take a while. 2 kernels, one for 32-bit and one for 64-bit. Yeah, wouldn't that be nice? That's the goal. The goal is to get upstream support for these boards. And one of the nice things about this actually is that by the end of the week, we're hoping to have a completely open source boot implementation that's published that is from the moment the internal SoC ROM releases control to the outside world. You'll have source code for everything that happens from thereafter. I think in the longer term, things like PSCI are going to be used to basically shield the proprietary pieces, but you'll be able to have open code that implements PSCI.
So there's no requirement to have an open source bootloader?
It's not a requirement, it's a strong recommendation. And I think one of the great things about what CircuitCo have done with this HiSilicon board is that we have had agreement from HiSilicon to make that implementation open source, because it's based on the ARM trusted firmware, which is open source, right? And then, but what you'll find is the actual detailed power management stuff behind PSCI. You won't see the source code for that. You'll just see a PSCI interface, right? We'll talk about that in the next session. So I can see you framing your next question. Anything else? How are we doing for time? A few more minutes if anybody wants. Yeah, Wiki.
So for this particular board, how many blobs do we need?
The only one you need, I think that I know, oh no, there's a couple. So you need one for Mali, you need one for the Wi-Fi Bluetooth chip, or two, can't remember, I think it's two actually, because you need one for Bluetooth and one for Wi-Fi. But there is pretty good upstream support for the TI, it's actually the TI Y-Link 8 module, and they have pretty good upstream drivers for it, but there's still the binary blobs for the IP. And then I think that's about it. There's a microcontroller blob that you have to load in the board to start with, but we never see that.
Well, those blobs can be readily available and easily accessible?
Sorry?
Are the blobs going to be available to...
Yes. Yeah, so the idea is it'll be a bit like the previous builds Linaro's done, where the idea will be you'll be able to boot the board straight out of the upstream kernel, but if you want accelerated graphics, you'll have a click-through license and be able to use it.
Can we get a frame buffer without the Mali driver? Does that not work?
Yes, it does work, but the performance sucks. So yes, you will be able to do that out of the box. Now what I'm hoping, my prediction is that this year we will see at least one board that has fully open source graphics. Wouldn't that be great? And actually maybe that'll encourage some other people, but graphics is hard because there's so much IP around it. Okay, well there are some boards out in the LNG room that people can play with. I think one of the things, there's some goals that we're trying to achieve this week in terms of getting more functionality on the boards, but I think the source trees are being published tonight. Is Fathy here? No.
Gone up.
They've gone up?
Yeah.
Okay. And so you can start having a look and a poke around. And as I said, if you are interested in taking a board home, just fill in the web form. We have a couple of hundred, so I think we've hopefully got enough for people to take, anybody who wants to take one. And what we would like is, so there's two things in terms of the way forward. On the consumer one, it's really about the companies who are involved, and there are a number of them already building boards. When you do want changes, we're probably going to have some kind of a change, a compliance. We're actually working through exactly what the compliance testing involves. But one thing will involve where a change effectively doesn't affect the rest of the community, i.e. you're introducing a change or you have a change requirement that doesn't actually break your compatibility with everybody else, or actually even if it does, we may grant you a variance as long as you document it properly. So for example, hypothetically, if you wanted to create a board and your SoC had HDMI but not DSI, and you didn't want to go to the expense of having an HDMI to DSI converter on the board, we might say, okay, we'll give you a variance. You can still call it 96Boards compliant, but you must notify that you can't support a DSI module, for example. So we're feeling our way here. As more boards come into the program, we'll play it, and there's funny things that are going on USB choices and things that people can choose. So we'll basically let this spec evolve, and we'll let the people who are building the boards come to us and say they've got change requirements.
As I've got the mic, do you know how many more you've got in the pipeline, as it were? This is the first hardware, but I guess there's some
Second
more.
one I think you'll hear about, no, we're physically expecting to see the next one within probably the next 6 weeks or so. And then there are a couple more that I know of that are coming behind that, and then there's another couple of companies who are not currently in Linaro who've said they're also going to do them, but they haven't joined yet. So there's kind of around 6 that I know of that are underway on this format. The place where we really do want input is on the enterprise version. And the reason is not because we don't know what we're doing. We've got a first one actually in design. What we're worried about is that there's so much variation between networking chips, server chips. Some people are saying they've got a chip this big for the server board, and can we leave enough space? And then I had another company who said they were building a 100-watt ARM chip, and I went, what? So how do we cater for that? So I just want to make sure that if you are interested, even potentially, in building a board around a networking or server chip, please review the spec or come and talk to us, because the spec actually isn't publicly published. Get a copy, which will give you, under a temporary just non-disclosure, because we don't want to publish it until we're a bit more final, and give us some input on it. So if you are interested in the enterprise spec, come and talk to Steve or myself, and we'll, unless there's a reason not to, we'll share it with you and get some comments. Yeah.
So how soon will the steering committee be able to start taking requests for changes to the spec?
So
Ready today.
now, how quickly will the steering committee do anything about it is another question. No, so if you do have suggestions, put them on the forum. I think there's a place in the forum, isn't there, Steve?
There is a specification forum.
So on the forum, start a commentary, add your comments, say this was a ridiculous decision, we think it should be this. And I think from the power management group you're saying, why don't you make those power rails mandatory? And as I say, one of the reasons was when we actually tried to make it mandatory, we found that the PMIC wouldn't support it. So,
so some of the ideas we have are around, okay, you have optional features, right? But we at least want to specify, at least recommend how people do that design. Yeah. Leave some millimeters of space around so we can actually solder things on there, and so at least put that as part of the optional specification.
yeah, yeah. There are places, particularly on the enterprise spec, where we've said it's optional, but if you do it this way, right? Anybody else? Do I give you a few minutes of your life back? There's probably coffee and goodies outside. All right, and please put input into the forums, comment, give us suggestions. We know we haven't got everything right, but I think we've made an excellent start, and I'm really excited by the opportunities for this. I think it's going to help a lot of companies. All right, thanks very much, everyone.